Seawater current energy, a much stronger force of nature, designed by engineer Michael V. Laxon. There's a lot of renewable resources available, but why seawater current energy? Coal-fired power plants. This source of energy existed before World War I. These days, developed countries are no longer using this as a source of energy because a lot of health organisations have proven it to be 100% hazardous to human health. But for some countries that are still using it, they will just bite the bullet that will kill their people later on. Windmill. So far, worldwide and even in the country, it has proven to be of great help as a clean and green energy. Yes, it is expensive, but this is what the world needs now to save our Mother Earth. But this source of energy is not sustainable, since strong force of wind is not mostly available. Solar power plant. Sunlight is not constant, so electricity must be produced from other sources at night or on cloudy days. Also, it is 35% more expensive than windmills. Huge land area is needed to mount wind turbines and solar energy panels. 10 years later, they realised that they needed the land for their agricultural needs. They then mount the post on shallow waters. This is where we got our concept from. The Earth is a watery place, but just how much water exists on Earth? About 71% of the Earth's surface is covered by water, and the oceans hold about 96.5% of all Earth's water. These are an alternative design that was developed for tidal water energy. These are all mounted below seabed and each have a submarine cable going to the power plant controls, and then delivered to the grid line transmissions, then to consumers. Developed countries' demands on designing new sources of energy that are clean and green, not using fossil fuels in form of coal and petroleum oils that produces carbon footprints that affect climate change. This is an existing smaller design of seawater current energy inside riverbanks that powers farmlands and fish ponds. It produces 0.5 megawatts using propeller drive, but our design is driven by paddle wheels. This was designed a couple of years ago, and this design is very expensive. Our design is 35% cheaper compared to all existing clean and green energy. Is tidal worth it? Some countries are still using this to save Mother Earth from global warming, even though they know it is expensive. Seawater is 832 times denser than air, which means an 8-knot tidal current has more energy than a 380 kilowatt per hour wind. And also, no expensive fuel is required. This is the blueprint of the general arrangement of the power barge as a power plant. It will house the plant manager, engineers, and the whole crew that will operate the power barge. The power barge will be anchored to an identified location that has strong currents that could be found in navigational charts and Google. This power barge could produce 250 megawatts, but a much smaller barge for 50 megawatts could be built, or a much larger barge for a higher wattage. These are the arrangements of smaller capacity of dynamos on 2 lower decks. The purpose of the smaller dynamos is for the paddle wheel to easily rotate the dynamos to produce faster RPM to develop the required voltage. The drive at both sides are called Azipod's drive that will start up during slack time of tide's nature. This makes the power barge 24/7 operational, non-stop, and will make this design sustainable. After the smaller dynamos have already produced higher voltage of electricity, some of the energy produced will now drive 0.5 megawatt dynamos to drive the bigger dynamos mounted on the upper deck of the barge and to the third deck. This shows the location of the paddle wheels that will drive our dynamos inside the barge. Above are the 2 levels of paddle wheel drives per deck. This is a blueprint of our design, a barge with a cone shape at each end, with extended gates to capture more force of strong water current that goes inside the tunnel. The barge is comprised into 4 parts. The base is the buoyancy that will hold the port section. The centre and starboard sections, where inside are the protected dynamos from water. And also, much better to maintain. The advantages of our design. Our design is based from the theory of windmill turbine. The dynamo drive was changed from propeller to paddle wheel. The propeller can only drive 1 dynamo from behind, while the paddle wheel can drive 2. Paddle wheel blades are more effective in water. Its width has more water drive. Deep water currents are more stronger than the ordinary tide flow. Our design does not need post mounting on the ocean floor, which is expensive. It does not need laying of expensive submarine cables per post. Posts are expensive to transport to the site, which is done one by one. Our design is made of barge. Everything is all in as a power barge. It's easy to travel to any site that has a strong current, and it will be anchored on the site. It is cheap to build and operate that will produce cheaper electricity. Design capacity could be built from 50 to 500 megawatts. The cost of this design is 35% cheaper compared to others, and it operates 24/7. This will help employment in the country. It will be sold as a cheap energy to other countries, which is also better for our economy.